Now we consider case 6. Again, I've included the equation, the standard equations, and here we are going to look at negative b values, where I still have a 2 to the minus x, so I have a negative x. That means my a here is a fraction, which I rewrote as a to the minus x. Again, I've just included the regular one, 2 to the minus x, the green graph there. So, and from there we will move on to the other graphs. Let us look at the blue graph. The blue graph is this minus 2 to the minus x, so b is minus 1. So the blue graph is the reflection of the green graph about the x-axis. Mirror image about the x-axis, and you can verify that by looking at the distance here. If you look at the distance here from 0 to a is 2 units, from 0 to b is 2 units, from 0 to e is a half unit, and from 0 to f is a half unit. The rest of the properties of the blue graph, the domain is still R. Since the blue graph is now below the x-axis, our range will be from negative infinity to 0. I do not have an x-intercept. My y-intercept is minus 2 to the minus 0, which is equal to minus 1. My vertical asymptote, I do not have a vertical asymptote, but my horizontal asymptote is again y equal to 0, or the x-axis. Let us look at the red graph. My b value is this negative 3 here, so b is negative 3. And first, my domain is all real numbers. My range is, since we are now below the x-axis, we start at negative infinity to up to 0. My y-intercept is minus 3 times 2 to the minus 0, which is equal to minus 3. My vertical asymptote, I do not have one, and my horizontal asymptote is y equal to 0, the x-axis. If I now look at the purple graph, then my domain is again R. My range, since I have a negative value there, it's all the negative y values, and my y-intercept is minus 4 times 2 to the minus 0, which is minus 4, and my horizontal asymptote is still the x-axis. So let us look at the graphs. If we label the graphs, then we get y equal to 2 to the minus x. This is y equal to minus 2 to the minus x. The red graph is y equal to minus 3 times 2 to the minus x, and the purple graph is y equal to minus 4 times 2 to the minus x. And we could have just used the symbols, but I want to use the formula so that you can check the values that we're discussing here. So if I look at the graphs here, you see this is the y-intercept of the 2 to the minus x, and minus 1 is the y-intercept of minus 2 to the minus x, and here we have the y-intercept of the red one is minus 3, and the purple one is minus 4. So how do we get from the green graph to the red graph? First, we take the green graph, we reflect it about the x-axis to get the negative, and then you stretch it vertically with a factor of 3. The purple graph is a green graph, reflected about the x-axis to get this negative 1, and then it's stretched vertically with a factor of 4. I've included a note again for you to compare those values. So what happens at x equal to 0, what happens when x is less than 0, and what happens when x is greater than 0. In this case, the green graph is strictly positive, so it will be larger than the other ones. But if I look at the negative, those below the x-axis, then if we look at the graphs that are below the x-axis, then we have to compare the absolute values of the b values, then minus 3 times 2 to the minus x will be above y equal to minus 4 times 2 to the x all the time. And those two, the red and the purple one, will be below the graph y equal to minus 2 to the minus x, because the absolute value of b there, which is minus 1, is 1. Finally, for case 6, we see that for x equal to 0, the y-intercepts are 1, minus 1 for the blue one, minus 3 for the red one, minus 4 for the purple one. And for x less than 0, y of a is greater than y of b, which is on the blue graph, y of c on the red graph, and y of d on the purple graph. For x greater than 0, the same happens. The green graph is above the blue graph, is above the red graph, is above the purple graph.